Hey, thank you for joining me. This is Psych 18 Research Methods, and this is the midterm 2 review. So chapter 5, children who read about George Washington and the cherry tree prior to being asked about Peking will respond differently than children who read about the tortoise and the hare. Is this a hypothesis, a theory, a research question, a prediction? This is a hypothesis. So the reason this is a hypothesis is it didn't really give a direction, but it's giving a prediction specific to the study, right? So it's those who are asked who read a certain story are predicted to have a different response than those who read the other story. So that's a hypothesis specific to the study. A research study describes self-concept as a person's overall sense of themselves as a human being. This description is an example of a or an. Is this a theory, a research question, operational definition, or conceptual definition? Well, in this case, this one is a conceptual definition. Overall sense of themselves as a human being. So this is the theoretical component of how self-concept is described. If this were an operational definition, it would have to be something specific, observable, and measurable. So perhaps self-concept, that could be some sort of established measure, a little survey, a questionnaire about how people perceive themselves, and that would count as an operational definition. It's obviously not a question, so it's not a research question, and it is not a theory. It's not trying to explain how self-concept is in people or how it developed. So that's why this is a conceptual definition. So you definitely need to be able to distinguish, an example of a theory as opposed to a research question, operational definition, or conceptual definition. So remember, theories should be broad and overarching. It should be meant to explain a phenomenon among all people or all situations. A research question is something specific, maybe an observation that is intriguing and you want to pursue. An operational definition of a construct is something specific, observable, and measurable. And then the conceptual definition would be a theoretical component. How does theory and previous studies define this phenomenon? All right, so this is just a recap of correlations. These are different types of correlations. The one in the top left that shows a correlation between self-efficacy and self-esteem, that's considered a positive linear correlation. Remember that whatever we have on the x-axis, which is the horizontal line, is technically considered to be the independent variable. It's the variable that we believe has more influence than the other one. Then the y-axis is the one that's vertical. So what we're saying here is as self-esteem increases, so does self-efficacy. So as the value of the x of the independent variable increases, so does the y variable value. Remember that in correlation, we are not establishing causation. We're just showing that there is systematic, predictable movement between the two variables. It's a relationship that we can predict. Graph B, as you go down, this shows a negative linear relationship. So on the x-axis is group size, on the y-axis is amount of noise. And what this is showing is that as the group size increases, right? Like, as the group size actually goes from low to high, you'll see the value of the noise actually decreases. So that's a negative linear relationship when the values are moving in opposite directions. So it shows that in the beginning, group size is small, the amount of noise is high. And then as the group size decreases, the amount of noise, as the group size increases, the amount of noise increases. In graph C, that's what we call a curvilinear relationship, in which case you see this is number of extracurricular activities on the x-axis and GPA on the y-axis. So in a curvilinear relationship, what you see is that for a short, for a period of time, it's a positive relationship, and then it reaches a peak, and then it starts to become a negative relationship. So this is a trickier relationship to find. You need many, many data points to establish it. Finally, we have no linear relationship, in which case here the x-axis, the independent variable, is amount of crowding, and the y-axis is performance level. So there is no correlation, no relationship between how much crowding there was in a group of people and the performance level of somebody. So those are the different types of correlations that we have. One thing to keep in mind with correlations is that the Pearson coefficient, the number, right, gives you how strong it is. The further away it is from zero, the stronger the correlation. Negative or positive does not affect the strength of the correlation. It's just whether or not the values are moving together, in which case it's positive, or if they're moving in opposite directions, in which case it's negative. But just keep in mind that like negative 0.5 is the same strength as positive 0.5. What it matters is how far away is that Pearson correlation away from zero. That's what matters. All right, so that being said, the older the children were, the less likely they were to peek at the toy. Is this a positive correlation, a negative correlation, curvilinear correlation, or non-existent correlation? Well, this is a negative correlation because as one value goes up, which is age, the other value goes down, which is the likelihood of peeking at the toy. So that is a negative correlation. Okay, now I can see it. Okay. All right, which of the following represents the strongest correlation? Is it R, which is the Pearson's R, equals 0.076, R equals negative 0.07, R equals 0.76, or R equals negative 0.77? Which one is the strongest association? It is negative 0.77. And that is because if you were to put these values on a number line, 0.77 is the furthest away from zero. Right, so make sure you keep track of the place values in decimals. Sometimes that tricks people. The negative, remember, does not make a difference in terms of how strong it is. It just says whether the values are moving, the same direction or opposite directions. But the actual value, 0.77, is the furthest away from zero, and therefore it is the strongest correlation. Okay, select all that apply. Which of the following is necessary to be present for a study to be an experiment? So you need to know there are 3 factors that must be present in order for a experiment. So is it establishing temporal precedence? Is it control over extraneous variables? Is it random sampling, or is it random assignment? Which of the following is necessary? It is everything except random sampling. So you have to establish temporal precedence, you need to control extraneous variables, and you need to have random assignment in order for it to be considered an experiment. If it's missing, even just one of these is no longer an experiment. The closest it could be is a quasi-experiment. How do experiments deal with a confounding variable? So select all that apply. Remember, a confounding variable is one that confuses researchers because the value moves together with the independent variable and the dependent variable. And so researchers don't know what's actually causing the change in the dependent variable, if it is truly the independent variable or if it's this confounding variable. And that's why it's called confounding. So is it through random sampling, random assignment, control, or there's absolutely no way to address a confounding variable? The answer is it's through random assignment and control. So random assignment minimizes the possibility that you're going to have systematic differences between the control group and the experimental group. And then if you have that there's a variable that What you do is that you exert control. So that's why you say it's through random assignment and control. Oops. Okay, what kind of design is this? You obtain two equivalent groups, randomly assign your participants to a group, introduce the independent variable, then measure the dependent variable. What kind of design is this? And feel free to unmute. It is a post-test only design. So in this situation, you can see you get your participants, you separate them into different groups, introduce the intervention, and then you measure the dependent variable. When you measure the dependent variable only once, it is considered a post-test only design. This is also a between groups design because you are splitting the participants into two different groups. They are not experiencing all of the conditions. How about this one? You have your groups, split, measure, introduce the intervention, measure again. What kind of experimental design is this one? This one is a pre-test, post-test only design. So the way you know it's pre-test, post-test is that you have splitting into two different groups, and then you take a baseline measure, introduce the intervention, and then you take the measure again. So when you could see, when you're measuring the dependent variable two times like this, then you know it's a pre-test and post-test design. So with these designs, remember what you're looking at is you want to see differences between time 1 and time 2. Any questions so far? All right, sample size effects. If you increased the chance of systematic variation, did you increase or decrease the sample size? You decrease the sample size. When you decrease the sample size, you are decreasing the diversity of your participant pool, and that's why we say that it's likely it increases the chances of variation. Okay, so result 2, if you increase the chance that the difference between groups on the dependent variable is a result of the independent variable, did you increase or decrease the sample size? Oops. Sorry. Try not. Not sure what happened here. All of a sudden I'm seeing the participants and not my screen. Sorry, let me just stop this for a second. Can you see the screen? I don't see it. Okay. See it now. Okay. If you increase the chance that there's a difference between the groups on the that the dependent variable is resulting from the independent variable, did you decrease or increase the sample size?
Increase sample size?
Correct. Thank you. Yes, when you increase the sample, what you're doing is you're actually helping to show that any difference between the two groups is because of the manipulation of the independent variable. And finally, do you have enough participants for 2 conditions? How many conditions? I mean, how many participants are you supposed to have for each condition minimum? You should have 30 minimum for each condition. So you want to have a minimum of 60 participants. Any questions about this one? All right. Post-test only or pre-test, post-test design. If the focus is on change in the individual participants' measure scores from time A to time B, is that a post-test only design or pre-test, post-test? That is pre-test, post-test. Whenever you have these two measurements of time A or time B, you already know, you should know that's a pre-test, post-test, because in post-test only, you only measure the dependent variable one time. Okay, may sensitize participants to research goal or hypothesis. Is that post-test only or pre-test, post-test?
Pre-test, post-test. There's a potential carryover effect.
Correct. All right, so which one requires less time?
This is post-test only.
I'm only measuring it once, right? Good, thank you. Thank you for unmuting and answering. All right. Format enables researcher to assess the equivalency of groups. Is that post-test only or pre-test, post-test? It's pre-test, post-test because you're taking a baseline. So when you take the baseline, that actually helps you determine, give you a sense of, are the groups actually equivalent through random assignment? Allows assessment of attrition. Pre-test, post-test, right? Because in post-test only, you're not going to have attrition. You've got them only one time. All right, ideal for experiments conducted over short time periods. Kind of like the other one, it's post-test only. So make sure you can tell the difference between description of pre-test, post-test, and post-test only. All right, so what kind of experimental design is it when participants are in all of the conditions?
Within group.
Correct, repeated measures or within groups. So in repeated measures within groups, you're not doing random assignment because they are in all of the conditions, right? Participants are first assessed for similarity on a pre-selected variable or set of characteristics, and then they're placed in different groups. So what kind of experimental design is that one?
Between groups?
It is, it's a special type though.
No. Um,
So
match pairs, yeah.
so in terms of internal validity, ideally, you do want repeated measures because what you're doing with the repeated measures is you're eliminating the possibility of like individual differences, right? Because you're looking at how are these people changing from time one and time two, and you actually have the baseline and you see that you're emphasizing that change. So that's the stronger between repeated measures and independent groups, right? However, there are situations where you can't have it repeated measures, right? Maybe the treatment changes the participants in such a way that it wouldn't work to have a repeated measures. So the next best thing is to have matched pairs. Again, what you're trying to do is minimize variation between the two groups. And so in terms of internal validity, matched pairs is stronger than just simple between groups. All right, so participants are randomly assigned to conditions and are only in one group. What kind of experimental design is that one? Between subjects or independent groups. Okay. All right. Okay. If you have each participant is assigned to all groups and the dependent variable is measured multiple times and the changes are compared, what is it? This one is within subjects. Why? Because the all groups means they're in all conditions, right? Dependent variable, here's another clue, the fact that dependent variable is measured multiple times. And what you're looking at is the change from time one to time two. That is within subjects, also known as repeated measures. Okay, each participant is assessed on his or her similarity to another participant based on a selected variable, then purposely placed in a different group from that participant. So with this, there's still random assignment that's happening, but you're making sure that the people who are similar to each other are purposely put in different groups. So what is this kind of design?
This matched pair? Yeah.
Matched pair. All right. Each participant is randomly assigned to one group. The dependent variable is measured, then the groups are compared. This one's just independent groups between subjects design, post-test only, because it's measured once. All right, so pros and cons, which one is it? The pros are the greater ability to detect statistically significant effect of the independent variable than a basic independent design. However, it's costly, it's time consuming, and there's a selection variable that has to be strongly related to the dependent variable to be effective. What kind of experimental design is this? This one's a matched pair, right? Matched pairs, participants are first matched by a pre-selected variable and then placed in different groups. So these are the pros and cons for it. Fewer participants are needed, extremely sensitive to finding statistically significant differences. Individual differences can be identified and explained. Cons to this design, limited external validity. Treatments that create permanent change cannot use this design, and there are issues from the sequence of treatments. What kind of experimental design has these pros and cons? Yes, it's correct, within subjects design or repeated measures. Okay, name the effect issues. What is it called when the sequence of treatment presentation can affect the dependent variable? What is that one called? Correct, order effect. It's able to open the chat so I can see what you guys are saying, or you can unmute. Feel free to unmute too. What is the effect where the first treatment influences the response on the second treatment?
It's carryover effect.
Yes, very good, Lynn. Okay, the deterioration of the participant performance on the second task occurs because of boredom, tiredness, or distraction. What kind of effect is that?
Fatigue?
Correct. What if there's improvement in the participant performance on the second task because of learning?
It is practice.
Yes. So I want you all to understand these effect issues are considered threats to internal validity because it's not because of the manipulation of the independent variable that's causing the change. So anything that is an alternative explanation to what can change values in the dependent variable, that is a threat to internal validity. So make sure you understand that component. Are there questions about this one? All right. Solutions to affect issues. Which one is it when there are all possible orders of presentation included? What kind of solution is that one called?
It's the complete.
Complete counterbalancing, yes. I think you were about to say that. It addresses attrition, but it causes difficulty in recruiting. What do you do to address attrition? So attrition, remember, is when you lose participants. And it also addresses difficulty in recruiting. So this is you have less time between conditions. What about it counteracts fatigue effects and carryover effects? What do you do when you have repeated measures that will help decrease fatigue and carryover? So this one is you increase the time between conditions. So the problem with obviously increasing time between conditions is it takes longer to complete your study. But and you don't want to make it too long. So it's really tricky as a researcher, you have to make that decision about how much time between, time 1 and time 2 before you measure people again. So that's one of the considerations. So if I were to visually show you an experimental design, and you see that condition A has these 4 individuals and they don't see TV. And then in condition B, you have 4 individuals and they see violent TV. What experimental design is this one representing? This one is actually within subjects, because if you see, the colors in the group from condition A are exactly the same as condition B, and there's the equal sign. So that means it's the same group in the first condition as in the second condition. So when you have an experimental design in which the participants are in all conditions, that would be within subjects or repeated measures. How about this one? You have your experimental design, you have a group, there's screening that happens, you split, you have them paired, there's a hint, and then they go into different groups. What kind of experimental design is this one?
Matched pairs.
Correct. There you go. And how about this? You have a group of people, basically their names are put in a hat, and then they are split into experimental group and control group. What is that kind of design? That would be a between subjects, right? You have your group, you're only measuring them once, there's random assignment, and they're in different conditions. Any questions about these? Okay. Important for all of you to understand the difference, between random sampling and random assignment. So the process in which participants are placed in conditions that are completely arbitrary and are beyond the control of the researcher, is that random sampling or random assignment?
Sampling.
No, it's assignment,
Oh,
because they're placed in conditions. Sampling is when you're getting them from the population, right? When you're talking about placing people, so process in which participants are placed in conditions that are completely arbitrary, that's what random assignment is. Questions about that one? Do you see the difference? The second one, I'll tell you now, that's random sampling. Every member of the population has an equal chance or probability of being selected for the sample. That's like putting everybody's name in a hat and you just pick them out. That's random sampling. So assignment. So something I want to make clear to everyone, when it comes to experiments, we understand as researchers, it is not always possible to have random sampling. What makes an experiment is random assignment. So you have convenience sampling going on. As long as you're randomly assigning one group to control and the other one to experimental, it should still minimize the chances of systematic differences. And that's what makes it powerful in terms of an experiment. Any questions about that? All right, let's move on to surveys. Okay, which variables can be used in research? Is it nominal, ordinal, interval, ratio, or all of the above? Remember that we had those scales of measurement. Nominal, ordinal, interval, ratio, or all of the above. Oops. It's all of the above. Because in survey research, let's go over this again. Nominal variables are categorical. So that's just different groups. So that could be, colors. What are your favorite colors? Red, orange, yellow, green, blue, violet. That's nominal. Ordinal variables are different categories like nominal, but now they're ranked. First place, second place, third place. Remember that surveys can be open-ended or closed-ended. So you could have a survey. Remember that in your homework, name the body part that hurts the most. What's second most? What's third most? So that's ordinal rankings. Interval would be Likert scales. That would be kind of, you could use scale answers in a survey measure. On a scale of 1 to 10, how much does your body hurt? On a scale of 1 to 10 or 1 to 5 or something like that, how much did you enjoy the movie? Those kind of things, that would be interval. Remember, interval does not have a true zero, a meaningful zero. Another example of interval is temperature. One thing I will say to you, if I say you need to be using the same variable, show me your understanding of the different scales of measurement by using the same variable, you need to use the same variable. So I've had students lose points because they'll, people remember temperature. Oh, temperature is a great example of interval, but it's not always going to, be the one that you have. It's not, temperature won't necessarily be the example you're supposed to be using. So remember that Likert scale works great for interval. And then ratio is the one we're most familiar with. If it involves a count of any sort, that's going to be ratio. If 0 is meaningful, if I say, how many books do you have? And you say 0, then I know that means you have no books. And so if it's something like pain, how many times did you say ouch in the last 10 minutes, right? Something like that. Any questions about the scales of measure? Because you're going to have to know this for the whole term. All right. Also, you need to know for surveys is this whole idea of Brusso. When we're talking about survey questions, you're supposed to keep this in mind because you're developing them, right? So B stands for brief. Make sure that the surveys themselves are not too long, but your question should not be overly long and complicated either. Relevant, only questions that actually pertain to the research question should be asked. Again, that kind of goes back to not being too long. Unambiguous, you shouldn't you shouldn't you read a question and not be sure what it's asking. So a lot of times it's those double-barreled questions that lead to things being ambiguous. So you want to be very simple and straightforward. Specific, the question should be clear and focused, only on one concept at a time. Again, avoiding that double-barreled situation or being too vague. And then objective, meaning the way you word things should not have those emotionally loaded words that try to direct people to answer a specific way. So those are the things with Brusso. So any questions about this before we kind of do some samples? All right, go for it. Which part of Brusso is violated? I kind of gave the answer to this already, by double-barreled questions. So is it being brief, relevant, unambiguous, specific, or objective? And it's more than one answer. It's violates being unambiguous and specific. So remember, a double-barreled question would be something like, do you agree that kindergartners should play with fifth graders and that they should be able to eat peanut butter? So that's a double-barreled question, because if somebody says yes, what does that even mean? Does that mean they think that these two age groups should play together? Does it mean they think peanut butter is a good idea? Both, is it only one? So that's why double-barreled questions are problematic, because even if somebody answers it, the researcher may not be sure what they're answering. And so anytime you have that, that's problematic. Which part of Brusso is violated by loaded questions? So an example of a loaded question is, do you agree that it is dangerous to have fifth graders play with kindergartners?
Objective.
Correct. So that violates being objective. So you want to avoid emotional terms, right? Closed-ended survey questions are useful for blank studies. What kind of studies? Closed-ended are like multiple choice questions like this, where the answer is there and you just pick it. So is it exploratory, qualitative, transcripted, or statistical?
Qualitative.
Close-ended survey questions?
Close-ended. Oh, statistical.
Yeah, qualitative, remember.
Sorry, quantitative. Yeah, yeah, yeah.
Exactly. That's I figured you're thinking that too. Qualitative focuses on words, so that would be open-ended survey questions. And quantitative is what you would use when you're looking at numbers, so statistical. So when you have surveys and you want to get a lot of information in a brief time, those are usually quantitative or statistical studies. Any questions about this one? All right. Let's assume each of the following questions is closed-ended, meaning a multiple choice question. If there's a problem with the question, state the problem and reword the question. If there's no problem, say so. Do you agree or disagree that poverty and hunger are among the most important problems in the world today? Is there a problem with that question, or is it fine the way it is? You can just unmute and say. Any problems with it? So this is a double-barreled question. What if somebody said, yes? Does that mean they're agreeing or they're disagreeing? You don't know, right? So that's one of the problems there. How about this one? After you graduate from college, do you believe it is likely or unlikely that you will not be able to find a good job? So you could have strongly agree, agree, strongly disagree, or disagree. But is there any problem with this question?
Wouldn't it be the same as the number one double-barreled? Because whether you answered yes or no, you're not stating if you're agreeing to the likely or unlikely.
Correct. That's right. How about this? Do you agree that improving the quality of our public school system should be a higher priority? As far as I know, that should be fine. During the past few months, have you consumed 5 or more alcoholic drinks in a row? Any problems with this one? The problem is it's not specific enough. Although it says 5 or more alcoholic drinks, past few months is too vague. So you would want to have something maybe like in the last 2 weeks or something like that, or last 14 days, even better. So you want to avoid anything too vague like that. How about this last one? What is your current college grade point average? 1, 4.0 to 3.0, 2, 3.0 to 2.0, 3, 2.0 to 1.0, or 4, 1.0 or less. Any problems with that one? What if you had a 3.0? Which one would you circle? Right, so the problem is that there are values that are overlapping and in two different answer possibilities. So it should be 4.0 to 3.0, 2.9 to 2.0, 1.9 to 1.0, 0.9 or less, or something like that. But you should not have values that are overlapping that way. Again, we want to minimize ambiguity, right? That's really important. How about this? Do you drink often? Any problems with that question?
Not specific enough. What does often mean?
Exactly. What is the average number of days a week that you have snacks? Any problems with that one? The problem is the word snacks is not defined, right? Again, I mean, what's a snack to some people? Some people, it's just nuts or something like that. But then for other people, that's a whole meal or whatever. So you need to be much more specific. What is the number of servings you eat in a typical day?
Also specific because servings is different.
And a typical day,
Yeah, in a typical day.
right? So is that 24 hours? Is that 12 hours? Like it's hard to say. Okay, so, okay, types of problems. Question. Did you drown in brew until you were totally blasted last night? Any problems with that question? Oh, please, someone say there's a problem with it.
Yes. There's just a lot of words that can have different meanings for different people.
Right. And I mean, it's not literal. Like, imagine if you're an English language learner and you're reading this, like, people are drowning. You know what I mean? So it's really very poorly worded and it's too much slang, right? Do you support or oppose raising Social Security benefits and increased spending for the military?
This would be double
Yes.
barreled.
Right.
Mhm.
Double barreled, right? Not clear on what people are answering here. Will you do your patriotic duty and vote today?
This not objective because patriotic duty is not specific.
Well, it's a loaded word, right?
Oh,
It is.
right, yeah.
Yeah, so it would have been better just to say, did you vote today? But to say the patriarch, you honed in on it. After you graduate from college, get a job and get settled, will you invest a lot of money in the stock market? It's too far away, right? What's a lot of money? You're asking somebody to project way too far in the future. So how meaningful would their answer be, right? That's the problem there. Do you think it isn't a good idea to build a new swimming pool, community swimming pool?
There's like a lot of negatives and it's hard to understand.
Right. All right. Any questions about the survey question? So you kind of get a sense, you need to know Brusso well, be able to identify problems, or even, maybe you have to reword questions. Any questions about this one, about surveys? The other part to the survey question area has to do with sampling. So there's quite a lot on sampling, probability sampling, and non-probability sampling. So here's an example. So I'm fond of giving people scenarios and stuff like that. Good Health Hospital of somewhere USA pays Triple Z Consulting to conduct a sleep survey of adults with full-time jobs in sorry, I should say Canada, not the Canada. Triple Z develops an online questionnaire and purchases advertising space on several popular websites. The advertisements invite fully employed people over the age of 18 to participate in a sleep survey. Within 2 weeks, 150,000 people respond, with 70% answering, I feel tired during the week because I don't get enough sleep, and 25% answering, I think I have a sleep disorder. When Triple Z reports the results, they state that 25% of today's fully employed adults feel that they have a sleep disorder, and 70% of fully employed adults who use the internet say they are tired during the week due to insufficient sleep. Is this a probability or non-probability sample? And if it's and specify what type. So that was the other part to the surveys, the different sampling methods. Is it probability or non-probability? Do you remember what probability or non-probability? So this is a non-probability sample because in a probability sample, you know exactly how many people you are drawing from. when you are doing an advertisement online, you have no idea how many people are seeing it. So it cannot be a probability sample. So right away, this is a non-probability sample. What kind of non-probability sample is it?
Self-selection?
Correct. Yeah, because people see it online and then they just answer to it. So would you say this is an appropriate or an inappropriate conclusion? Based on what they did, to say that 25% of fully employed adults feel they have a sleep disorder, and 70% who use the internet say they're tired during the week due to insufficient sleep.
That's inappropriate because not all people who use the internet reported to this survey.
Correct. And not only that, the first part, if you look at it, it says 25% of today's fully employed adults. Again, that makes it misleading, right? Because you only have 25% of those who participated in the survey feel that way. And that doesn't really give a sense of how many people, even though 150,000 is a huge sample, it's still an inappropriate conclusion. Any questions about this one? Okay, so let's move on to quasi-experimental designs. So this one, there's quite a few, and yeah, you need to have a good sense of what they're like, right? So which design is it when you have participants, right? They are measured on the dependent variable. The intervention is introduced, right? Take a look at that. So you see the top one's the experimental group, the bottom one's the control group. The dependent variable is measured again after the intervention is introduced. The intervention is introduced a second time, and then you take the dependent variable. Again, what kind of quasi-experimental design is this one? So you have to kind of track what's going on in each of the boxes. So this one is pre-test, post-test with switching replication. So let's go through this. It's pre-test because the dependent variable is being measured before anything is introduced. So that's the pre-test part. Then you have the introduction. If you look at the first IV, you see the experimental group gets exercise, the control group gets no exercise. Then the dependent variable is measured again. That's the post-test component, right? But the independent variable is introduced a second time, but this time you see that what was the control group also gets the intervention. That's the switching replication. So the experimental group gets the exercise again, but in the second time the intervention is introduced, the control groups gets it as well. If you remember, ethically, you're not supposed to prevent a group that could benefit from having the treatment, right? This is a carryover from the Tuskegee trials, right? So what many researchers do is they don't prevent someone from completely having an intervention that will help them, but they introduce it in a staggered way. And that's the switching replication. Any questions about this format? Okay, what about this one? You get periodic measurements of the dependent variable. You implement the independent variable, and then you take periodic measurements of the dependent variable again. Which type of quasi-experimental design is this one? Correct. This is interrupted time series. So this is a very powerful, this is really powerful in terms of internal validity, even though it's quasi-experimental and there's no random assignment. What makes it so powerful is you have so many data points, right? What you're having is yours, like if you, in the example on top, you have a period of 7 weeks when behaviors are being tracked. Then you introduce the intervention, and then you trace it again for another 7 weeks. So that really eliminates the idea of other possible explanations. So on the top graph, what you're seeing is a treatment that worked. That's what you want to see. You have all these behaviors, you want to see a decrease in it, and look at very obviously in the second part, there is a change. What you have in the bottom part is a treatment that did not work because you see that their behaviors did not change at all. Any questions about this one? Okay, how about this? What design is this one? Participants, they get the dependent variable measured. Independent variable, the intervention is introduced. Dependent variable measured again. Independent variable introduced, and then dependent variable measured again. What is going on here? So here, this is switching replication with treatment removal. So this one's very similar to the one I talked about before, where you have the kind of pre-test, post-test idea. Again, look at what's happening in the boxes. So you get the baseline with the pre-test dependent variable being measured. Then you have the intervention. So you see the experimental group gets exercise, the control group gets no exercise. Then you measure the post-test dependent variable after the intervention is introduced. But look what happens in the second time. The experimental group gets their treatment taken away. They have no exercise. And now the control groups gets their treatment and they get the exercise. So you want to see by the third time, you measure the dependent variable. So let's go through this. Pre-test dependent variable first time, that's the baseline. Then you introduce the intervention. What you want to see is the experimental group have an improvement in their post-test dependent variable, and the control group, you're not expecting to see any change, right? Then what you do is you take away the intervention from the experimental group and you introduce it into the control group. So now you want to see a change for the worse in the experimental group when you measure it the third time, and you want to see improvement in the control group because now they have been exposed to the intervention as well. Not always appropriate, right? Depends on what the intervention is. And of course, we have to think about ethical implications. But this is, again, really powerful. The more data points you get, the stronger your internal validity, because numerous times when you're collecting the data. Any questions about this one? Okay. Threats to internal validity. Just going to kind of review this. Very important. You're going to hear this word over and over again. Non-treatment participant change, there are two types. There's maturation and there's history. When we're talking about maturation, we're talking about usually a physiological change within the participant. The reason that's a threat to internal validity is because it's not because of the independent variable that's causing the change, right? So an example of maturation is, maybe you're doing a study with kids, and in the time that you're doing the study, they hit puberty or something. And so this is changing their cognitive perspective or things like that. That is maturation. That's truly a threat to internal validity. History, on the other hand, is something that's happening outside of the participant, usually in some kind of social context or environment that, again, causes change in the participant, and it is not because of the intervention. Example of history would be the COVID pandemic, right? Anybody who was doing a study at that time, their results are going to be flawed because, the whole shelter in place thing really affected people. So these are what we call non-treatment participant change, right? Important to recognize. Another threat to internal validity would be measurement errors. Two types of measurement errors. One is instrumentation. So instrumentation happens when you have a change in the measuring instrument. So let's say you're, maybe measuring somebody with blood pressure monitor. and you don't realize that the battery's starting to die. And many of you might know, when batteries start to go, the readings are flawed and can go really awry. So that would be an example of instrumentation. Another example of instrumentation is regression to the mean. So regression to the mean is a statistical event where very extreme scores over time tend to move toward the mean. So very high scores will drop down and very low scores will increase. That's what regression to the mean indicates. So that, again, these are changes in scores that do not have to do with the manipulation. And that's why it's a threat to internal validity. Any questions about these? These are from time-related variables. These could happen over time. Okay, so non-equivalent groups design threats to internal validity. I think this is one of the homework questions. So it's not that selection, it's considered selection differences because you are not able to randomly assign people. And this is what weakens quasi-experimental studies as opposed to experimental studies. So differential effects, meaning that there are actually systematic differences between groups, right? The reason you're using quasi-experimental is because it's either impossible or unethical to randomly assign people into one group or another. So just the very nature of quasi-experimental designs, there will be systematic differences between the groups. That's why we call them non-equivalent groups design. The assumption right off the bat is these are not equal groups. Then you have the interaction of selection variables with another test threat to internal validity. What do I mean by that? Well, not only do you have these systematic differences between groups, but that compounds things like maturation. So it makes it even a bigger threat to internal validity because now you're having that interaction of already being different because one group may know, maybe they have some kind of illness, plus maturation, or you have this group that has a difference plus history. So that's what we mean by an interaction with the systematic differences. All the threats of internal validity become compounded when you have no random assignment present. Oops. Other things that could be problematic are types of bias, right? So assignment bias is that even aside from things that already exist, maybe because the researcher wants their hypothesis supported, they're making sure that certain people with distinct differences are in the experimental group, right? To increase the idea that you're going to see a difference between them. So that's assignment bias. And that the selection interaction is what I mentioned earlier, that it's that interaction of having the threat to internal validity like history or maturation or instrumentation in conjunction with the systematic differences between the groups. So any questions about quasi-experimental design? All right, let's move on to factorial designs. So one thing I want to emphasize is that factorial designs happen with any of the other research designs, similar to the changes over time. So you can have a survey, a factorial survey, because as long as you are investigating more than one independent variable, that becomes a factorial design. So I just want to make that clear that this is not necessarily always with experiments. It can be with experiments, quasi-experiments, surveys, observations, can be any of those things. As long as you are interested in more than one variable, it becomes factorial. Another component I want to emphasize is that oftentimes the second variable is what we call a non-manipulated independent variable. If you are at all interested in possibly gender identification differences, male identified, female identified, non-binary, that's a non-manipulated independent variable, and that could make something factorial, right? So let's say you were interested in the effects of sleep on cognitive performance, but you believe that there could be differences, maybe biological. So then you want to analyze for something like if they're biologically male, biologically female, or something like that. You're not manipulating that, but you do believe that it's a factor that's important to consider, then that becomes a factorial design. So by far, factorial designs are very common because people are complicated. And a lot of times you want to look at, more than one variable. So I just want to make it really clear to all of you, when you're doing a research proposal, if you say you want to do it factorial design, I'm going to go back and say, what kind of factorial design? Because you need to be specific. The whole purpose to the research proposal that you'll be writing is to show me that you actually learned the information and you're able to apply it to the proposal. All right, so let's get started. What type of effect is this? So remember, with factorial design, you had main effects, interaction effects, and simple effects. So given some data and a graph, you should be able to tell me, is there a main effect, interaction effect, no effect? Looking at the data and the graph, what type of effect is it?
No effect.
Correct. Why is there no effect? The values are all the same, right? So it didn't make any difference at all. How about this? Are there main effects? Are there interaction effects? So remember, when you're looking at main effects, it's the average overall conditions, right? So when you're trying to figure out main effects, I think it's actually easier to look at the data. So let's take a look. So the independent variable A is noise level, and that is up in the orange. And then the independent variable B is temperature. So look, on average, when things are quiet, right, the average score is 475. When things are noisy, the average score is 455. So that tells you there actually is a main effect of noise, right? There's a difference between the two. Now let's look at temperature. Average score when it was cold is 475. Average score when it was very warm is 455. So you also have a main effect of temperature. Now, if you want to know if there's an interaction effect, the easiest way to look is on the line graph. If the lines are crossing or starting to converge, then you know it's an interaction effect. Any questions about interpreting this one?
Dr. Estrada, for any lines that aren't parallel, is it appropriate to say that if like extrapolating the data points further, they'll eventually cross, or do they actually have to physically cross on this section?
As long as they're not parallel, you can assume that they're going to converge.
Gotcha. Thank you.
Any other questions? Okay. How about this one? What kind of effect is it? So I invite you to look at the data and look at the graphs. What's one thing you can see looking at the graphs right off the bat? Is there an interaction effect?
No, the lines don't cross.
Correct. So there is a main effect, but is there a main effect of both noise level and temperature, or no?
Just on the noise level?
Correct. Right? So did you figure that out from the graphs or the data?
From the data.
So I will provide you with both. Okay. And then how about this? Main effect, interaction effect, no effect.
Interaction, they cross on the graph.
Right. There is an interaction there. No effect of temperature, right? That's why it's completely level. So when you see it's perfectly flat, that's no effect. but there is a main effect of the noise level, right? So that's why you see that there's a main effect of noise level, but it depended on there was an interaction there. All right, how about this one? So here, look at the data, right? You see differences. So there's quiet and noisy, there's a difference there. Cold and very warm, difference there. So you know there's a main effect of noise, main effect of temperature, and looking at the line graph, they are not converging, so there's no interaction effect. Okay, and how about this one?
Interaction and only a main effect on temperature.
That is correct. All right, last one. So here, looking at the data, are there any main effects?
No.
Correct. Is there an interaction effect? Yeah, there is,
Yeah.
right? So it is possible to have interaction effects, but no main effects. And that's what makes factorial design so powerful, is it is the only type that can detect an interaction effect. So it makes it more, it's much more efficient than having two different studies. And it can also find interaction effects where if you conduct two separate studies, you wouldn't find that at all. Any questions about the factorial designs? So you should be able to know, remember, the independent variables are going to be examined separately. So a fully within factorial design means both independent variables are going to be within subjects' designs. So I might ask you for an example. Give me an example of a 2x2 fully within subjects factorial design. When you give it to me, it needs to be something that makes sense that it'd be the same people in all the groups, right? So you could do something like this where you're doing noise level and temperature. Sure, it could be the same people being tested, whether it's noisy or quiet or cold and very warm, that's fine. But then let's say fully between subjects, so you need to be able to describe to me the levels and also how can you explain, always explain to me in a short answer why you're giving me the answer. That way, even if it's wrong, I can try to give you credit, right? Fully between subjects means that you're going to have different people in every condition. So you could have, if you're talking about age groups, for example, you could have adolescents and emerging adults as, age group would be one independent variable. And then the other independent variable, it could be, maybe amount of sleep. Right? So you could have different people in each one. So you could have some adolescents sleeping 5 hours and some adolescents sleeping 10 hours and some emerging adults sleeping 5 hours and the other emerging adults sleeping 10 hours. And they're all in different conditions. That would make sense as a fully between subjects research design. And then you have mixed factorial design where you have one independent variable being studied as within groups and the other independent variable being studied as between groups. So your example, right? So if it's a fully within subjects design, I shouldn't see things like age group or race or ethnicity or gender identification because they're going to be between groups just because of the nature of the different categories, right? So make sure that your designs make sense when you give it, and they're very likely so. In these exams, you're gonna have different questions, right? And so I'm not sure whether you're gonna be questioned on, give me an example of a fully within subjects factorial design. Or you might get the one that says, give me an example of between both a mixed factorial design. Just make sure that your example makes sense and take the time to explain it. Right, so a dorm on the university campus has started a Go Green Facebook campaign focused on persuading students to turn out the lights in their dormitory rooms. Dorm residents received emails and messages on Facebook that encouraged energy-saving behaviors. At the start of the campaign, the head resident noted how many kilowatt hours the dorm was using by checking the meters on the side of the building. At the end of the 2-month campaign, the head resident checks the kilowatt hours again. She finds that the number of kilowatt hours has dropped. She statistically analyzes data and finds the difference significant. Some questions, and you won't have 10 questions on one thing, but you will have a number of questions. I might ask you, based on this scenario, what is the research design? What is a possible hypothesis? What are the independent variables and dependent variables? I would also likely ask you, what is the research design here? Right, so if you read it, right, okay, so they had a campaign. They get emails and messages. And if you read it, at the start of the campaign, the head resident noted how many kilowatt hours the dorm is using. And then at the end of the 2-month campaign, check the kilowatt hours again. So gives you a hint of what kind of research design we're talking about here. Are there any threats to validity? Right, so these are kind of short answer questions that I would very possibly ask you. So make sure you feel comfortable taking a look at this and being able to determine, okay, this is pre-test, post-test, because they measured it, twice before and after the campaign. In fact, maybe you could even say you could argue that, oh, this is interrupted time series because they measured it first for a little while and then it went through 2 months. What are threats to validity? Well, what if they went on vacation? What if the 2 months encompassed Christmas break? And so the fact that the kilowatt hours dropped may not necessarily be because of the campaign. So just be able to explain your reasoning to me and you will get credit for that. Any questions about this example? Okay, another thing I might do is give you an abstract of a study and again, ask you questions about it. What kind of design is this? What conclusion can you make? Are there threats to internal validity? Those kind of things. I want you to get used to being able to look at an actual study and be able to draw this important information. Excuse me. Excuse me. I just want to, we have about 8 minutes left. This is the kind of a summary of the different research designs that you should be familiar with. You've learned a lot in a very short period of time, right? This is the accelerated version of the class. This summarizes everything you should know, right? Experiments. What are the different experimental types? Post-test only, pre-test, post-test, between subjects, match design within subjects. We have correlational studies, which are purely quantitative. We have observational studies, different types. Naturalistic means that they're in their environment where you would find them on a daily basis. Disguised means that they don't see, excuse me, the researcher at all. Case studies are also considered observational. In case study, you're looking at just one person, kind of examining what's happening to them. This is qualitative. And then archival research entails getting publicly available documents or primary source documents and making observations through that. So something like social media posts would actually count as archival research. Looking at other people's studies that they've published is not archival research. So I just want to make that really clear. Developmental designs, you have cross-sectional, longitudinal, sequential. Again, these designs would encompass something else. So oftentimes developmental designs include a survey, or maybe there is some kind of observational component to it. All cross-sectional means is that it's a group of people, different ages, one point in time. Longitudinal, you have people of the same age and you follow them over time, maybe bring them back every 2 years or something like that. And then sequential, you start off with the cross-sectional group, different ages, and then you follow them over time. So that's what you have for these different groups. Any questions about those designs? Okay, other studies, qualitative. We're focusing on words and interpretation. These are fantastic for learning more deeply about people's experiences. Oftentimes we do this through interviews or focus groups. Qualitative studies focus on the interpretation of what people are saying. And so when it's qualitative, what you have to do is you have to establish something called inter-rater reliability, because two people have to be able to look at the transcripts and be able to interpret it the same way. Similar to observations. Observations are also qualitative. So two different people should be able to look at these observations, these recordings, anything like that, and come up to the same conclusion. That can be extremely challenging. You have to get a 0.8 correlation of agreement between people's interpretations of observations and qualitative data. Surveys are by far the most common, right? These are quantitative, they're quick, they're fast, they're cheap, they're easy. That's why they're the most common type of research study. So surveys are correlational. Now remember that surveys can have both close-ended and open-ended questions. So you could have both quantitative and qualitative components in a survey. The big issue with surveys, of course, is response rate. So it depends on how the surveys are actually conducted. Of course, face-to-face has the highest response rate, highest completion rate, but very expensive because you have to pay people to go conduct these interviews, right? Far more frequent are these online interviews. Problem with that, of course, it's self-selected sampling. It's people who decide to answer. And there could be systematic differences between them as well. So there are a lot of different components to consider when you're looking at these different research designs. So if we were to go on a spectrum of experimental on one end and non-experimental on the other hand, quasi-experimental, of course, is much closer to an experiment. They're only missing one component to experiment. Oftentimes, it's not having random selection. So the different research designs are one group post-test only, one group pre-test post-test, and interrupted time series. For non-equivalent group designs, we have many more different types, right? Post-test only non-equivalent, pre-test, post-test non-equivalent, interrupted time series non-equivalent. Then you have the switching replication, and switching replication with treatment removal. So it's really about following, look carefully at the boxes, what's happening. How many times is the dependent variable being measured? That's a big clue. What's happening when the interventions are being introduced? Those being able to understand that will help you identify it. Remember, you can also have a handwritten cheat sheet, both sides. So it might be a good idea to do little drawings of that so that it helps you remember. Okay, so I recommend that. Any questions about these different research designs? All right, so in terms of matching, it's going to be questions about sampling techniques. So I might give you a description of what it is. You tell me what kind of sampling technique it is, or it might be a question about a research design and, description of it or purpose. So those are the two types of matching that you might end up with. Short answer. What might some of them be? Like I mentioned, could be an article analysis where I give you an abstract, you identify features, levels, threats to independent variable, maybe questions about results. A I might ask you to give examples of threats to internal validity. Again, I might give you a little study description and answer questions about that. Also, in terms of research designs and validity, explain how blank affects the blank validity of this research design. So explain how sample size affects the external validity of a survey design or something like that. So those are kind of questions that might pop up in short answer. So make sure you're prepared for that as well. Questions? All right, so these are the different types of sampling methods. Remember, probability and non-probability. Probability sampling, everyone has an equal chance. You know exactly, how many people are in the population. And so you can use probability theory to determine the likelihood of them being selected as a participant. So you have simple random sampling, stratified random sampling, and cluster sampling. And then for non-probability sampling, the 4 types are convenience, quota, purposive, and self-selection. So make sure you kind of know that. And remember that the sampling frame is what we call like kind of the operational definition of the population from which you are deriving your sample. Questions about this one? Okay, last summary, the threats to internal validity. You have the environmental variables, right? Whether the study's being happened day or night, that kind of idea. You have experimental expectancy effects, where they're interpreting ambiguous situations or responses to support their hypothesis. I talked about the measurement errors already, non-treatment participant change, order effects. We have these systematic group differences, right? We have these differential effects that are happening because of maybe selection bias or that interaction between, not being able to randomly assign people and the other threats to internal validity. And then you have reactivity. So reactivity is when people know that they're being studied and it changes the way they respond. So demand characteristics are if they think they know that the hypothesis and they want to respond in a way to help the researcher. That's not good, right? That actually hurts the internal validity because they're not being authentic. And then social desirability is when they answer in a way that they believe will make them look good to others. Oftentimes this would happen if they think somehow that their responses can be traced back to them. So you want to try to reduce that by making it anonymous and assuring the participants that they're not going to be tracked. And that is it. Any questions? I will stop sharing at this point. And oops, I want to end the meeting. Are there any questions? I do want to stop the recording.